Hey everyone, today we're going to look at a grade circle. I had someone email one of these to me looking for guidance. If any of these videos are helping you, please like, subscribe, and tell your friends, and I'll keep them coming. So step one is to write your givens. I always like to take the pertinent information from the problem. In this case, it's just our lat 1, lat 2, longitude 1, longitude 2. To make this easier, I like to, step 2, convert your minutes to a decimal. The way you do that is you take your minutes of your latitude and you divide them by 60. So 57 minutes for latitude 1 divided by 60 will get you 95. You add the whole number and you'll get 31.95. The way that looks, if I'm doing longitude 2, 52 divided by 60. I take that decimal and add the whole number, 115, and you get your longitude 1 in decimal form, 115.86 degrees east. That's step 2. Step 3 is to calculate your difference in longitude. And the way you do that is by simply subtracting longitude 2 and longitude 1, but it's a little bit more complex than that. I like to visualize it with a Mercator projection. It looks like this. My version of it is just 180 degrees on either side of 80. So you have 100, or you have 0 to 100 east, and then from the left it's 80 to 100 east, with west being in the center. Our difference in longitude in this case is going to be 115.87, our longitude 1 minus our longitude 2, 66.98 for a difference of longitude of 48.89 degrees. Step 4 is to plug into our formula here. We have our cosine, or our distance formula is cosine distance equals cosine lat 1 times cosine lat 2 times your cosine difference of longitude plus or minus your sine of lat 1 times your sine of lat 2. And you'll see that in the orange down here I have an asterisk. When crossing the equator, you choose the minus sign. So you can see when I'm filling in this formula, I'm using the minus. We're crossing the equator. You tell that because our latitude 1 and latitude 2 have different signs. We're starting in the north, we're starting in the south, finishing in the north, so we'll use the minus sign in this formula. The way you type these into the calculator is exactly as you see it. We'll do a parentheses, cosine 31.95 times cosine 48.89 times cosine of difference of longitude 24.78. Close parentheses, we get a decimal of 0.506. We'll then do the second half of that problem, sine of lat 1, which is 31.95 times sine of latitude 2, 24.78. Close the parentheses, we get a decimal of 0.221. When you subtract those, you get 0.284, and then you'll do your second cosine to get distance alone. Second cosine, 0.284, for a distance in degrees of 73.5 degrees. So here's step number 4. Step 5 is to convert your degrees to nautical miles. So we just got 73.5 degrees. To convert that to nautical miles, you will times it by 60. Why? Because there's 60 nautical miles in 1 degree. So 4,410 nautical miles. You can see that our answer is going to be C. That is the closest to our distance. So we're already on the right track. We just want to finish this problem out to ensure that we have 2 confirmations, the distance and the initial course. Step number 6 is to plug into the formula and calculate your initial course. Again, remember that when we're crossing the equator, which we are, south to north, we will use the minus sign. The starting point for this is plus or minus your sine of latitude 2 minus cosine d times sine of lat 1. So we'll use the minus sign there. And let's not forget to make sure we apply that. In this case, it will be our sine of lat 2, 24.78, 0.419. I have that here. I have added my minus sign, and we'll do the second half of that problem. Minus, cosine 73.5, or cosine of your distance. And remember, we're using our degrees for our distance here. I did convert that to nautical miles, but for the initial course formula, we're using our distance in degrees. So cosine 73.5 times sine of 31.95, which is our latitude 1.150. I have that here. So negative 0.419 minus 0.150, and then I'll do the bottom portion as well. So sine of our distance is 73.5 times cosine of lat 1, 31.95. Close the parentheses. We get 0.814 rounded up. So now we can do this. Negative 0.419 minus 0.150. Negative 0.569 divided by 0.814. And then we simply just do a second cosine, second answer to get the answer we just got in there. And we get 134.34. So that's our initial course. How do we assign this a direction? Let's plug this into the formula. This is going to be step 6. We take our direction from our latitude 1, which is south. We take our difference of longitude, which the direction is west. Why? Because we're starting at 115 degrees east. We're going easterly towards 66 degrees east. So we take our sine of our latitude 1, south, our direction of our distance of longitude, west, and we are going to put in our northeast southwest, we're going to put that course 134.3. That's southwest. So we're in the south, we're moving west 134 degrees. So that's going to put us in the northwest quadrant. We're going south for our latitude, and then to the west 134.3 degrees. Now we have to get a true bearing. This will be step 7. We have our 134.3 degrees to the northwest. We need to calculate that from north. So we'll take this, we'll go all the way to our starting point. From south, we have 134.3 degrees, and from the north, we have 180. So 180 plus 134.3 gives us a true course of 314.3 degrees. That is going to be step 7. C is going to be our answer. And remember, when we're using our initial course formula, we want to use our distance in degrees. And remember, when we are crossing the equator, we want to use the minus sign for both the distance formula and the initial course formula.